Right, let's kick off day 2 with a joint presentation with Passive Bolt on what kinds of benefits IMSE has for home appliance design. And Passive Bolt is our customer, which TactoTek supported to create their award-winning keyless entry system, Shepherd Lock, of which you will also hear more about soon. And now I'm very pleased to introduce Sini Rytky from TactoTek.
Hi guys.
And Kabir Maika from Passive Bolt.
Hi everybody, happy to be here. Thanks for having me.
Thank you. And Sini, please take it from here.
Thanks, Tua. Also welcome from my side. Today we're going to start with a short recap on what is possible with IMSE, then continue discussing about the challenges and IMSE solutions for home appliances, and conclude with our customer Passive Bolt introducing their Shepherd Smart Lock. But let's start with the basics. What can you actually do with IMSE today? The foundations are called IMSE platforms, those being all the verified materials and components from conductive inks and components, and all the way to different film and plastic substrates and their combinations. On top of the platform are the technology modules, which we call IMSE building blocks. Those form the functional features that are selected based on the customer need and respective use case, obviously. We've divided the IMSE building blocks into 5 different categories. Touch for capacitive sensing elements, Sense for example, proximity sensing, Illuminate for example, small functional illuminated symbols, or a more non-functional larger area ambient illumination type of feature. Then connectivity, printed antennas and coils, and ultimately the look and feel, different kinds of surface materials and treatments for the ultimate look and feel of a IMSE part. Also, these are the functions that are currently integrated inside the in-molded IMSE structure. In addition to these functionalities, the IMSE structures can be complemented with external structures as well. So for example, the haptics actuators can be incorporated with an IMSE part if there is such a need. Then looking at the home appliances in particular, the human-machine interface is one of the most important points of contact, obviously, between the product and a user. At its best, the HMI provides intuitive and responsive controls for the customer and also contributes the overall design of the product. With home appliances, achieving cost-effective differentiation between brands is also difficult. An appealing HMI as part of the complete design is one of the keys towards brand differentiation and standing out in the eyes of the consumer. Now, as users, you and I, we all navigate through, I would say, dozens of different HMIs and designs every single day. They are often compromised by the boundaries of conventional electronics, and often it takes significant time to learn how to use a new appliance, for instance. At its best, great HMI doesn't only provide the intuitive and responsive controls, but also enables beautiful design features that really bring the experience of using a product to a whole new level. Let's take a look at some of the main challenges for conventional components in a box structures and how we can help overcome those challenges with IMSE. Now, creating HMIs that define brand identity is significantly limited in terms of shapes, styles, and functionality. And very often, customizing the HMI in terms of cosmetics, functionality, or both requires new tooling, at the very least for some parts of the conventional assembly. Also, creation of seamless surfaces with functionality, great looks, and easy to clean properties is very difficult, and typically will force the design to some kind of compromise. Now, secondly, with conventional methods, the total cost efficiency, it's really a difficult task to manage. Due to complex part structures, that create a need for multiple tool sets, assembly line setups, and often complicated labor-intensive supply chain as well. And thirdly, every electromechanical interface is obviously a reliability risk at the same time, as well as many times a high-priced line item in the bill of materials. With increasing demand for more sophisticated controls in the HMIs, managing both the cost and reliability risks becomes more and more challenging. So, looking at those three major topics, let's see how we can help overcome those challenges with IMSE. Designing a three-dimensional HMI with IMSE enables the use of functional design elements as brand identity elements. These could be as simple as an illuminated power button with brand-specific geometry, for instance, or a more streamlined full HMI design language that is consistent from every appliance throughout the different product categories. The HMI is also extremely thin, which opens up a whole new world of design possibilities, not only for the geometry of the part itself, but also in terms of where the HMI can be placed. So what it means in practice is that since the HMI is so thin, it can go over the appliance surface, which enables the customization of the HMI without actually having to make any changes to the surrounding mechanics, which means that the appliance is then customized as late as possible in the assembly process. Keeping surfaces clean is very easy, and there is no risk for damaging the HMI or the components inside because all the functional features are encapsulated in plastics. So they're completely protected from, for example, debris and moisture, and safe to be sanitized as well with most common household cleaners. Secondly, let's spend a little time on discussing the total cost efficiency. Now, since you all know that the IMSE part is a single piece structure, so it's created with a single injection molding tool. This cuts down the tooling expenses significantly compared to conventional structures. Now, this applies both to the actual fabrication of the tools, but also to the related design and engineering work for those tools. With IMSE, most of the assembly steps in production are removed. Functional and graphical localization for IMSE is done with printing, which then eliminates the time-consuming and often expensive tooling changes for different localized variants. What the reduced complexity also means is less time and effort spent on design and engineering, less components to manage in the inventory, less vendors to manage, and significantly simplified flow of goods altogether. And as the third major item, looking at the competitive edge, one electromechanical interface that results in durable and reliable structures while keeping the HMI safe from external hazards at the same time. Now, the advanced intuitive functionalities from high sensitivity capacitive switches with beautiful illumination to, for example, incorporating a wireless antenna radiator directly onto the structure, and basically anything from the building blocks that we just shared before. Any and all of those functionalities can be mixed and matched based on the customer and use case requirement. With the ability to transform the HMI design into 3 dimensions, providing intuitive guidance for the user by designing smart geometries directly onto the part. This could be anything from a subtle texture on the surface or a guiding geometrical feature that guides the user to interact with the HMI with ease. And last but not least, the IMSE enables the creation of consistent HMI logic in a single part structure that can be customized to deliver and carry the brand identity throughout the product categories, providing elegant and more so familiar functions for the end user that are easily recognized and easily learned by the users as well. So to summarize very briefly, IMSE enables new ways for brand differentiation, but does it with total cost efficiency, resulting in competitive edge. Next, we will hear more about that competitive edge from our customer Passive Bolt. Please, Kabir, over to you.
Thanks for having me. Pleasure to be here and talk about our product Shepherd, and also to talk a little bit more about Passive Bolt and all of our activities as they relate to IMSE. So, just for the sake of this conversation, I'll just briefly be going over roughly 4 slides. First, we're going to just talk a little bit about Passive Bolt, a little bit about us, what we're about, who we are, that kind of stuff. Next, then I'd like to do a quick overview of our product Shepherd, and also then next discuss what IMSE utilization we've leveraged in the design and implementation of the product. And then finally, why we chose to work with IMSE as opposed to some of the existing technologies. So Passive Bolt, we're based out of Ann Arbor, Michigan. We spun off from Continental Automotive actually about 2 years ago, back in 2018. Continental was one of the largest automotive tier ones, where I was formerly the lead. I was technical lead for keyless entry systems for vehicles. That's technologies that let you, seamlessly or in a highly convenient way get in and out of a vehicle, and also the start functions. So what we've done with my core team is decided to really leverage, all of that experience that we have with keyless entry from an automotive point of view, and deliver, that in the smart home, albeit in a different form factor. So we said to essentially redesign, our solution so that it fits within smart home, but really delivers the user experience that consumers have come to like and appreciate when using an automobile, in the sense of walking up to your door, touching the handle, unlocks, go in, push a button, start and go. Really simple way to to utilize your car without having to juggle keys. And in this process, I'll say, as a company, what we've done is created a beachhead brand, which we're calling Shepherd, that allows us to essentially deliver that value to the customer. It's sort of our proof of concept brand, but really at the core, we're more of a B2B focused company, where we're working with companies that, let's say we would call home automation companies. So companies that sell portfolios of smart home products. You could think of, home security companies, MDUs, builders, etc. So companies like that, where we offer them the ability to take a ready-made, tested solution that they can brand and take to market. So, Shepherd, which is the product that, I was talking about, is our, let's say, our flagship brand. The way it works is truly extraordinary. You can see the product here in that picture on the right, with that smooth finish, with all of the functionality built right into the cover for the interior use. It is a retrofit lock. What that means then is obviously you would install it on the existing lock set chassis. So in this case, you can see from this picture, this is inside of the home. Our product adapts the existing deadbolt. So outside, you keep that same existing deadbolt. Inside, you install our product easily with just 2 screws, and you put this cover right over it, which is what's visible in this picture. But once you do that, then you unlock some of the key automotive features that we have, right, which we're bringing here. So that's the touch, as an example. You can touch your existing deadbolt, and no, it doesn't need to collect your fingerprint. It's utilizing virtual keys, just like the vehicle does, right? So we triangulate and locate the key. We run a challenge, it passes, it unlocks. In milliseconds, you could touch your lock and it unlocks automatically. You go in. Once inside of the house, you can also touch the lock and unlock. You can see that finger, it's essentially on a touch sensor, which basically from inside, for egress purposes, no keys required. It would lock and unlock the door instantly. And on top of that, we brought some, additional features that are also unique to the market. So the conversion that I just mentioned of a, traditional deadbolt into a touch-activated device is a first to market from Passive Bolt. But second, we also added some security features leveraging our touch technology, which allows you to be able to detect, perhaps, for example, when somebody's trying to pick a deadbolt, and it would freeze the lock temporarily as long as somebody's attempting to pick the lock, sound an alarm. communicate with our partners, control panel as an example, right? Same thing with, a first-to-market brute force detection, where if somebody kicks down the door, an alarm goes off, homeowner gets notified. But on top of that, we have one more technology that's enabling actually the brute force, which is the ability to know when the door is open or closed, or really anywhere in between, leveraging a built-in sensor technology that we've developed, which does away with the need to drill Hall effect sensor onto your door frame, which is the state of the art, right? So that's one more first to market from Passive Bolt. Again, with these and many more innovations that we brought to the space, we've received the CES Innovation Award for 2020 this year. We've received many more awards, such as being nominated and shortlisted for the best consumer IoT coming to market in 2020, and ultimately being one of the few companies, along with Amazon, that were honored at IoT World. Mentions in top 7 for Forbes for 2020 technologies, etc. So we're really proud of Shepherd as a flagship brand, flagship product that we've designed, which incorporates IMSE technology and is delivering innovative technologies. In terms of IMSE, I'll cover the way we've implemented, the way we've utilized it in this product. So this is the face of the product. This piece is our IMSE component, the black piece. And as you can see, it's got a built-in LED. So this illuminated feature is essentially printed onto the plastic cover. So it's IMSE based. And that allows us to provide an indication of feedback to the user seamlessly. We've got the touch sensor right below that, which is that rectangle. It's not as evident in this picture, but the finish is slightly different for that touch sensor surface, which signals to the user, this is where you touch. So you can issue a touch command for locking and unlocking the door from inside of the home. And then at the bottom, we have a printed logo. Again, that gives us flexibility as a B2B company in terms of being able to swap out that logo in future iterations, right? The finish itself is just clean, smooth, and elegant. In this case, it's a glossy finish, but with IMSE, we're able to iterate that finish again just by changing that top layer. So that gives us a ton of flexibility in terms of the different finishes we could take to market without retooling or changing the design in any way. The cover that's around it in silver is plastic, and it's magnetized. So the black cover, the black piece just snaps right into it. And the whole assembly between these two, the black and the silver, could be removed from the product without using any tools. And that's how you access batteries, to swap out the batteries. But you can see here that the use of this IMSE technology allows us to have good touch, LED, and a design that could be iterated in terms of logos. So then I'll tell you why we chose IMSE instead of using conventional technology to achieve this, right? But one of the driving reasons is that if we wanted to create a touch sensor for inside, we would have, because our circuit board resides below the plastic, we would have had to design a method, a way of basically conveying touch all the way to the surface, right? But in a way that's still limited to that touch surface that we've determined and not go beyond that. That has proved to be incredibly challenging in terms of reliability, robustness, and quality prior to IMSE. But with having the ability to print that sensor right on the surface does away with set complexities. So we're able to minimize tooling, which is the second great benefit here, able to essentially deliver that touch feature in a way that is seamless. But you can see, I mentioned earlier that the cover is actually removable, because what we've done is we've divorced the aesthetics from the functional piece, which we're calling a module, that sits right below that cover. If you remove that magnetized cover and you get access to this module, then in order for us to actually have the ability to have an LED feedback on the surface, a touch sensor, we would have had to come up with a complex tooling strategy to get that done. But with IMSE, because it's fully printed into the plastic and a clean finish, all we needed was just to leverage a few pads, connection pads, small and sort of up to the side. We're able to convey, we were able to connect to the cover and be able to convey feedback to the user without needing to resolve or at least take advantage of complex tooling strategies. This makes for a really robust, reliable design where, the touch is highly robust. The LED, the elegance, and the, fullness of the LED indication that you get is priceless. But more importantly, as a B2B company, once again, the ability to change that logo without having to retool. When we're talking to, let's say, a regional home security company that we're supplying, right? This gives us flexibility. It gives us the ability to sell them a branded solution, aka a white label for us, branded for them, where if they weren't able to support volume, say beyond 10K, would be able to just swap out a top film with their logo included, and that gives us flexibility, in terms of our ability to satisfy market needs without having to incur costs or charge NRE costs to set customers to create additional tooling, right? That's a really big differentiator for us, the way we see using conventional molding versus IMSC to achieve these features.
Thank you, Kabir, and thank you, Sini, for your excellent presentation. And now let's have a short panel discussion. So first, Kabir, going forward, how do you see the smart lock industry develop in the coming years? And what do you think are the main functionalities that the future smart locks will carry?
Yeah, thank you. And the way we really see the smart, lock space developing is, a renewed and continued focus on user experience. User experience is king. The whole point of a hardware product is that it be intuitive, easy to use, and that homeowners or users, generally speaking, are able to derive a great experience. Meaning the UX must be great, and so we see touch as a critical function of that. That's sort of core to our design approach anyway. The ability to just come and do something as easy as touch to indicate what you want, as a means of, let's say, measuring user intent, is a powerful way to enhance user experience. And we've leveraged that, and we expect the industry to continue to leverage that moving forward. We expect facial recognition to rise up as well as a means of authentication, therefore eliminating the need for, let's say, a mobile phone or fob, etc. Again, that continues the same trend, which is improving user experience, right? The ability to just walk up, be recognized just because of your face, and then be able to just touch to issue a few commands. That level of intuitiveness brings a certain elegance and a certain, just, let's say, oneness with technology. And that's where we see the industry going.
How about you, Sini? What do you think?
I think we share a lot of similarities between our thinking with Kabir as well. And obviously for TactoTek as a company, we need to make sure that our technology enables that improved user experience, which in many cases today means that we need to be able to increase the electronic functionality that actually is embedded in the devices. So from future development point of view, we basically have three themes where we focus. So first being to increase the amount of IMSC platforms to serve the rapidly increasing amount of use cases for IMSC, which basically means the verification of material stacks that act as basis for any IMSC product design. Secondly, as Kabir mentioned, touch is one of the key elements in the smart locks today and in the future as well. Our roadmap also considers adding new functionalities with the IMSC structures. So going from basic capacitive single sensor or multiple sensor structures to, for example, trackpad implementations, or for example, new building blocks for illumination features. And thirdly, we really focus on increasing the amount and complexity of electronic components that can be in-molded within the IMSC structures. And actually, how we are planning to go about that, you will hear more in our coming technology vision presentation today.
Exactly. And then about the shepherd lock, which Kabir, you already discussed in your presentation. In the Shepherd Lock, you have brought an innovation from the automotive industry and adapted that into a smart lock. So do you see this type of technology adaptable for other smart home applications, such as smart home controls, for example?
Absolutely. I mean, I think, there could be more use of touch surfaces, of, let's say, built-in LED feedbacks, etc., such as things enabled with the IMSE piece as part of our Shepherd Lock design. But more broadly, though, I think there needs to be some level of uniform, like a uniform user experience, uniform UX across devices in a smart home. We see smart locks as just being one piece of the home automation, let's say, system. So if you're really looking to provide a homeowner with a full home, smart home, let's say, experience, it behooves you as a designer to consider, that all the devices that are being connected share some level of, let's say, user experience, or some level of consistency in terms of how the user experience those devices. So it would make sense to have an entire smart home package that carries the same design philosophy throughout. So we definitely see room for extending our design approach, design thinking, user experience approach to devices beyond.
Okay, how about from TactoTek point of view, Sini?
I would definitely like to see a smart lock in my refrigerator from time to time, maybe to block me from using it. But I think overall, the way we see the smart home controls develop is that all electronic devices in our homes are coming smart. So they are increasingly embedding, for example, connectivity features that allow the consumers benefit from additional services that are made available by the OEMs. Also, what we see is that the devices carry increasing amount of functionalities, like for example, the Shepherd Lock. It's not just a lock, but at the same time, it's also your home security system that lets you know if your door is left open, for example. So the increased amount of functionalities obviously set certain challenges then for the UI, HMI, and the UX design. And being able to provide new design freedom in terms of, for example, three-dimensional shapes is essential. And I think also one thing that applies to the smart home environment is the kind of shy-tech approach, which we have already learned about in yesterday's presentations, where basically all the technology is hidden until you need to use it.
Right. Yeah, I would also like to see the smart lock in many other places as well. For example, in the fridge door, like Sini mentioned. Gabriel, you already mentioned that you've started shipping products and primarily you are first targeting the US market. So what are your plans on expanding your technology into other geographies?
Yeah, that's a great question. Thank you, too. I think next up, we're going to go to our neighbor up in Canada. That seems like a natural fit to expand, north. But down the line later in 2021, we're going to be going across the pond over into the UK market and then beyond that into the EU market. That's our roadmap for global expansion at the moment.
All right. Sini, from TactoTek point of view, how does this sound?
Sounds great. We are looking forward to see Shepherd locks in Canada next. From TactoTek point of view, one of the key elements of TactoTek strategy is to grow an entire IMSE ecosystem, both for components and material supply, but also for the IMSE parts design and manufacturing. Our technology licensing packages enable the OEMs to use, for example, their existing supply chains, use globally available materials and components that are industrialized as IMSE platforms. And obviously, we want to make sure that our customers have the fastest time to market with IMSE technology.
Okay, excellent. Now, it's unfortunately already time for us to close this panel discussion. So I would like to thank you, Kapir, and thank you, Sini, for being here with us today. And would you like to send any greetings to the IMSE Days audience?
Thank you, everybody. It was a pleasure speaking here today, and I appreciate you two all for having us. Thank you, Sini. Have a fantastic rest of your day.
Thank you also from my side, and thanks, Kapir. It was nice to talk to you again. And greetings to our audience. Let's keep the show going.
Exactly. Thank you from me as well. And soon it's time for the next presentation.